Hello there and welcome again to my workshop. So today we are going to make this 12mm ball screw fit in this top slide. Now to do that there's basically three operations that I have to carry out. And the first one is to bore this drilling out here. It's probably better if I get it off and show you, and we can get it off simply just by undoing these. And there you are. So what we're talking about, because this is much too big for that hole. In actual fact, this is 12mm, and that's 12mm. But you know, being cast iron, it will go in there, but it's not enough to be able to allow this to operate properly. So I'm going to be boring this out. Okay, so I'm boring that out to probably about 14mm, which is 12.75 is half an inch. So I'm going out just a couple of sizes over half an inch, and then I'm going to be milling this section out here a little wider, maybe possibly a little deeper too. We're only talking about maybe taking 1mm off each side, or just under a 1/16 of an inch off each side, and off the base as well. Now in addition to that, I'm going to be taking the nut off the screw, which is a fairly simple task really. You just machine up a piece of plastic pipe or tubing that's the same size as the bottom of the race down in there, and you wind this off and you push the tube in as you're winding it off. That way you don't lose any of the balls. And because I need to turn this around on this screw, and also I need to machine that side off, this side off, and the bottom. Now this is very, very hard steel. Now what I normally do is I get a slitting saw actually, and I take it off with that, rather than put it in and mill it off. Because a milling operation, you know, it would take a minimum of 3 milling operations, and providing you don't cook these up, because there's nylon parts in here as well, so you've got to keep it cool and do a little bit at a time, and I think I can grind that off quite successfully. And really all I'm interested in keeping is that grease application hole there and drilling, and that top securing hole there. That's the only things I'm interested in keeping on that flange. The rest can go quite happily, because you know the load that this is under is very minimal really when you're talking of a lathe this size. So you know, you don't have to, it's not under any tremendous strain. And I did the same process with the mini mill, and I will remind people that I converted a SIG X2 to CNC, which is by the side of me here, and there are some 12 videos I think that I did about 2 years ago, so you'll see those on my channel, and I've also put them in a playlist as well, which makes it easier for you to find. So you might be interested in those as well. And I'd like to, at this point, put a big shout out there to my patrons, because without their financial assistance, you know, none of this would be possible at this level. So thank you very much, guys. And if you are interested in becoming a patron, please pop along to my patron page. And again, thank you very much. So to machine this, I can't do this in my little mill there. I've got a large manual mill, which is over the other side of the workshop, and we're going to set this up in there. And also I saw a few comments a month or so back when I bought my 4-inch engineer's vise, and you know, I put it on the mini mill and it sort of dwarfed the mill, which I knew was going to happen anyway, but really I bought that because I knew I was going to do this, and I knew I was going to require you know, a larger and more precision vise for handling things like this. So we'll go over now to the big manual mill, and we'll set that up with a vise and set this up in it and start machining. Okay, so this is the setup. I've got my 4-inch engineer's vise on here now, and this hole is just a shade over 11.5. This hole is a shade over 11.5 millimeters. So this is an 11.5 millimeter drill that slips in there quite comfortably. So what I'm going to do is I'm going to put this into the chuck, and I'm going to center. Let's do this up tight. So I can center this over and find out the center of that hole. Okay, so it's going to come this way, a shade, and it's going to go that way. Make sure it goes all the way through without binding, which it does. So that's perfectly on center now. So I can lock that up and lock this one up. I've got manual locks under here that I can tighten down on the gib so it stops this moving around. And now I can change this drill out and just bore that hole out. This manual mill, now if you was going to get a manual mill that you really wanted to do, you can do some precision work on this. Get one with a dovetail column, cast square column. Don't get the round tube columns at the back, they will flex, these don't. I've had this for 25 years and it's never missed a beat, and I've used this for a lot of jobs. It's got a 6-speed gearbox on it. Maximum RPM is 1600 RPM, slowest RPM is 95. I've toyed with the idea of making it a variable control, and that could quite easily be done. But it's straight gear change at the moment. It's set at the moment on its slowest speed, which is 95 RPM. It's also got forward and reverse motor control, and it's 2 horsepower motor, which is 1500 watts. So that's the slowest speed. Now we're doing cast iron, so we want a slow speed that's a little bit too slow. So you change gear just like that. You can just catch out of the shaft and just rock it back and forth to select the gears. It's a little bit like a truck gearbox, I think. Yeah, that'll be okay. Alright, so that speed's just about right. Now, I've got a slow mechanical feed. That's a lot of winding work, so, and I don't really need that. So I think I can manage quite well with just the manual feed here. So let's bore this out. And I'm actually boring this out to 15mm. I've decided I can get 15mm, which is half an inch is 12.75 millimeters. So you know, it's a shade over half an inch, which would be what, 9/16? About 9/16. I can tell you straight away. Inches, 0.59 of an inch. So I've noticed on there that a few of you are asking for inches measurement. So this is me telling you inches measurements. So what's that? 590 thou. I think it's 9/16. 9/16? No, not 9/16. Yeah, it is 9/16. Thereabouts. Okay, so let's drill this out. That went fairly smoothly. So what I've done now, I've laid it flat down because I've now got to machine the inside out, and this is a 3/4 inch 4-flute end mill. But now I've got to lower the complete head down to be able to machine this now. So that's okay. For this next operation, I've got a tungsten tip ball mill, which I'm just lining up there in the center. I'm going to take about a 2 millimeter trench in the middle out, and I'll probably widen it a little. And I want to go about 2 millimeters deep. About there. So that's our next operation. See how this one goes. So what I'm going to do now is just take a little bit more meat out of this side and a little bit of that side, and that'll do me. Okay, so we just finished machining this. So you can see I've taken a trench out of the bottom there. If I can get the light. Taken a trench out at the bottom, and I've taken 1.5 millimeter out of this side, 1.5 millimeter out of that side, and of course I bored that out 15 millimeter, which gives me plenty of room for this ball nut and this zero backlash thread. Okay, how to turn that around, because there's a million balls in there and we don't want to drop it out all over the floor. So it's quite simply done. Now I've just gone over to my lathe very quickly and just turned a bit of plastic up. There's a millimeter wall, so the bore is that size, okay, and the outer diameter is the inner diameter of this track. Simply what you do, hopefully, put it on there like that, and you unscrew it, and that should, the balls should run up on the outside of this, hopefully, otherwise I'm going to be in trouble. Okay, very steadily. Very steadily. Well, it's going through. Sorry, can you see that? Just got to have a little bit of finesse doing this, because if you get it wrong, so you can see it's climbing now onto the plastic. It's on the entire plastic now. So now we can pull this off gently, like so. Turning that around. Put him on that side. And hopefully, there we go. Let's turn around. Just got to re-put that dust shield back in. So that's how to turn a ball nut on the race. And hopefully Okay, perfect, that's the way we want round. So my next job now is to cut this off. That's a joy as well. So you can see it fits in there quite well now, with room to spare. Okay, right, well that's fitting in there perfect actually, but I do have another bit of machining to do on the cross slide, and I've marked out on the cross slide, then I'm going to be picking that up, get a bit of light on it. You can see that scribe line is in line with these drillings here. This is where the old cross slide nut was, so it's slightly off center, and of course this is the line where the new ball screw runs. So I've marked out there the center line of the ball screw and as far back as I want to machine back. So I've got to take about 2.5 mil deep, but I'll probably take 3 just to give me clearance. And what I'm going to do, I'm going to see if there's enough room there to pick up that top nut. Sorry, I'm going to see if there's enough room that I can get a thread in there to pick up this top hole. If not, I'll pick up the 2 side holes there. The job I'm doing now is I'm actually cutting through the ball nut and removing the material that I don't want. A couple of tips here, because this is, it's a fairly expensive item, it's a very accurate item. There's nylon parts inside this, so you do not want to cook this up too much, and you don't want to damage your screw thread. So I'll put some insulation tape on it. That serves 2 purposes. It stops the nut undoing, or it stops the threaded rod dropping out through and you loosen your balls all over the place. And it gives you an indicator if things are getting warm too. So what I do is I grind a little bit, dunk it in the water. Okay, grind a bit, dunk it in the water. So it doesn't build up too much heat. So you got to hold it by the actual ball nut body carefully. It takes a bit of time, but you will get there in the end. And just take your time, do it bit by bit, don't let much heat get into this, and you'll be fine. It's in, and it works. So to all the people who's left So to all the people who left comments saying, that ball screw's too big, you'll never get it in there, and you ought to get a smaller one, well, it does fit. You know, it's gone together without a hitch, really. There's been some fiddly things, but you know, it's been pretty good. And I've got the 70mm travel that I was looking for. Previous it was 60, so I've increased the travel by 10 millimeters. You know, I'm thinking of making sort of a gang tool post. In other words, 2 tool posts, one here and one over here. I'll fit that on at a later date. Maybe. It seems like a good idea anyway. And you know, everything's pretty straightforward. Nothing sort of really dramatic with it at all. And I think the next job that I'm going to do is I'll make I've got a housing to make to go on here, which is going to house the thrust washers. The bearing actually fits in here, so I'll get this completed up and to the point where, you know, I want to put the standoff on, and I'll make a common standoff, the same as I did with the mini mill. So I'll make those together. So yeah, you know, it's going very, very well, and I hope you're enjoying the videos watching. I'd like to take this opportunity to thank my patrons. Without their help, you know, I couldn't possibly work at this level that I am, or maintain it. So again, patrons, thank you very much. And I'd like also to thank you viewers for watching my videos. And don't forget, press like, subscribe to my channel, and you know, there's over 350 videos now on both my channels. So I think we'll leave this one here, and the next one then will be finishing off this X axes, and then, you know, putting the standoffs on, and you know, if I can get it in the same video, we'll build this end up as well. So thank you for joining me, and it's bye for now.